Bam. No coughing. Hello and welcome back to Calculus 1. I guess for one last time. Oh no, that's going to be tomorrow. Today is Tuesday all day, right? Yeah. All right. So we are going to start section 5.5. As I mentioned before, this is, if you are taking Calc 2, your lifeline. So the first two chapters will mainly depend on this section because basic integrals are cool to know, but they are not as frequent in problems as these guys are. So we start from understanding that this is backwards chain rule. So you know that most of your derivatives were chain rule, so it would be natural that most of the integrals would be the anti-chain rule, which is actually U sub. So here in blood, this is backwards chain rule. And because the chain rule is the most frequent derivative you encounter, this must be the most frequent. Now, when you learn other integration techniques in Calc 2, Chapter 7, most of those techniques would be manipulation to transform the problem from its current state into a state where you can use U sub. So that's why it is very, very frequent. And obviously, a lot of Chapter 6 integrals, like 90% of them, should be U sub integrals. Now, what is this all about? Well, let's say you need to take the integral of x plus 1 squared dx. Of course, you can FOIL this quickly into x squared plus 2x plus 1, and then quickly integrate into x cubed over 3 plus x squared plus x plus c. Here's the plus c back because we don't have the limits, right? It's indefinite integral. I hope you have plus c's on all of your integrals. And so that's that. But what do you do when we say x plus 1 raised to 27th power dx, right? Are you going to FOIL this 27 times to get a polynomial and then, right, work on each one? And the answer is obviously no, right? We're not going to do that. There has to be something cool to solve. And obviously, since we're dealing with math, we do have cool things to do this. So what I'm going to do is I'm going to recognize that if I keep all of this as a one variable, call it u, then I would just have u to 27, which obeys the plus 1 rule, right, the polynomial rule. So on the side, I say let u be x plus 1. And now, since I am transforming the integral to go from variable x into variable u, I also have to transform dx into du, and that I can simply get by differentiation. So du dx is 1. And then I can move dx to the other side. So du is exactly the same as dx for this transformation. That's not always the case. So now you do replacements, which substitution. Whatever is here in green, that's your x plus 1 becomes u to the 27th. And then instead of dx, I get to write du because that's the link we got this time around. And now this integral is transformed from something that would really be pain in the neck to FOIL into something that it's easy because we get u to the 28 over 28 plus c. But the problem was posed in x, and we have our solution as u. which means that we have to now change the variable back and go substitute 1 over 28, and instead of u, I have x plus 1 to the 28 plus c. And now you can see that the answer is in terms of x. So you get used to this as you do problems over and over again. Let's see another example. Say you have integral of x e to the 2x, e to the x squared dx. All right. You look at this and you said, I know how to integrate x on its own. I know how to integrate x squared on its own. I have no clue how to integrate e to the x squared, but I can integrate e to the x. So you found something that could be changed, right? Instead of having e to the x squared, maybe I can have e to the u, which would be the x squared. So let me try and say that this u is x squared. I'm just going to try. It might not work out. And this is something that you have to get used to because you're learning this. There's going to be a lot of failures when you try homework. You have to persist and say, okay, it didn't work out. Let's try the different thing. And then you keep trying until you can't have more than 3 or 4 different possible things that you can do in every problem. So if one thing doesn't work, try the other 3. Something will eventually work if you persist. And then you will develop the intuition on what exactly needs to be chosen. So what's du over dx is 2x when you take the derivative and then ship the dx to the other side. And look what we got. I have that du is 2x dx. And if you remember that there are multiplication signs everywhere, right? You already have x dx. See, there's x dx. What you are missing is 2. Constants can be fixed by you plug in the 2 and you plug in 1/2 in front, because 1/2 times 2 is 1. So you are not changing the problem, you are changing the appearance of the problem so you can actually do it. So what I did is I fixed the problem by putting in that 2 and countering 2 with a 1/2 in front of the integral, because 1/2 times 2 is 1, which means I didn't change the value of the integral, but I did change the appearance. It's like, same you, different shirt, right? So now what I have is 1/2 integral, and now I have this 2x dx. That all is du. And I have e to the u, because e to the x squared is u. Now it's a basic integral. What's the integral of e to the u? E to the u plus c. And then we go back to x. As I say usually over here, I don't care about u, I care about the x. And then you just replace it, right? Good. So 1/2 e to the x squared plus c. This is going to be the last problem for today, to just as the introduction, but I want to introduce the idea which I developed when I was a student to understand this better, and that is function derivative pair. You always have to have function derivative pair in order for this to work. And you will see in Calc 2 that when the function derivative pair is not present, you will be looking for other techniques of integration. So right now, obviously, all of these problems are rigged to work. But then, hey, later on, there will be trig substitution. There will be partial fraction decomposition. There will be integration by parts. There will be all these other methods of integrating in Chapter 7 where you are not going to have these features. So I call this function derivative pair. This is the first thing that tells me that I'm supposed to do u sub, but also helps me pick what's u, because function is always u, and the leftover, which is the derivative, would be du. So do I see a function derivative pair in this problem here? And the answer is hell yes. I see if I pick x squared as a function, I have x, 2x, I can fix that, as a derivative. So function derivative pair, and function was x squared, that was u. In this problem here, do I see a function derivative pair? Of course. I see x plus 1. I see that as a function, and then the derivative of that is 1, which always exists. So in multiplication. So that problem was not that great for understanding function derivative pair. This is more advanced, like for the spicier problems. So here is the spicier example. Say you say sine to the 8x times cosine x dx. See, you can understand this sine to the 8x as sine x to the 8, because that's what it is actually. These two are the same, except the notation is different. Now, do you see a function derivative pair that could help us here? Which one would you pick as u? Sine. Because its derivative cosine is present. So, if we pick u equals sine x, then du dx, which is the derivative, would be cosine x. And then du is cosine x dx. Oh, I have it. Nice. So this is just u to the 8 du. Oh, how awesome is this? We took the entire sine x, replaced it by u, and then everything else just mushed into du. And the whole problem now is 1 over 9, u to the 9 plus c. And then we go, I don't care about u, I care about the x, which means 1, 9, sine 9, x plus c. We can do one more. So I hope these problems will be enough for you to at least start the homework in this extremely important section. Usually 2 or 3 problems on the final from this, and then half of your Calc 2 grade depends on this, like half. One more problem. Say integral of x squared cosine 4x cubed dx. So how many functions do we have? How many functions do we see? 3. Very good, 3. We have x squared, we have a cosine of something, and we have 4x cubed, right? So there are 3 functions. Now, u has to be one of those 3, because that's all you have, right? Which one is it? Which one is the only one that has a derivative present? Give a chance to someone else, because I know you know. Which is the only function there that has the derivative present? X to the 3rd. Very good. Its derivative is x squared. Yeah, the constants will play the role, but you see a cosine, its derivative is negative sine, and negative sine is not there. Previous example, yeah, both sines and cosines were there. That's why function derivative pair was sine cosine. Now you don't have sine, so function derivative pair are actually polynomials. So u equals 4x cubed, which is what you wanted. And what's du dx? 12x squared. So du is 12x squared dx. I don't have 12. I don't have 12. Yes, multiply 12 and 112 in front. Fix it. Is that the attitude when the car breaks? Yeah, it's broken. You just walk away. That's it. Just abandon it on the road or whatever. It broke. Like you went grocery shopping, you put all the groceries in the car, you start, it doesn't start, and you just say, it's broken. Actually, that's what we're developing with all this Apple computers mindset. That's what they are. Yeah, that's the type. That's what they're promoting. That type of ignorance. It's like, yeah, it's like, oh, it's broken, so yeah, we'll just buy a new one.
Max lasts so much longer than Windows lasts.
Yeah, I know. That's why you buy a Toyota when it dies. It's just, yeah, it lasts longer than Ford, I guess. I don't know. 112 cosine u du. So I hope you guys see that this part over here is u. So you have cosine u, and then all of this multiplied is du. So that goes there. Now here's my color coding. I'm gonna leave this. It looks terrible. So now I am integrating cosine u du. And what's the integral of cosine? Positive or negative? Ah, I got you. You said it right the first time. I'm just a terrible individual. So it's 1 over 12 sine of 4x cubed plus c. And that will be the answer. Now, how do you check take the derivative? And we'll talk about that next class, because I always loved integration because it was so beautiful. Every time you solve, you take a quick derivative, you know immediately it's right or wrong. That's why I loved integration. I liked integration more than derivatives, even though it's harder. I liked it more because it was always an easy check. For derivative, you hope it's right, right? But this one, if you're not lazy and if you care, take a quick derivative. Obviously, it's going to be chain rule every time. And done. That will be all. So see you tomorrow for part 2, and the review finally is in 1 day and 22 hours.